Alright, this is part 3 of our review of quadratics. We're factoring, we're solving, and we're factoring some more. Alright, we are supposed to factor the following polynomials, but we must always remember what is the first step of factoring. That's right, GCF. What is the GCF of this trinomial? Hopefully you notice that they are all divisible by 5. So let us pull out that 5. Now, when you do this, please understand that the next thing you want to do is divide by your GCF. So we're going to make one big old parentheses. Okay, the GCF is 5, so I'm going to divide everything here by 5. Okay, that lets me know what to put inside of these parentheses. So 10 divided by 5 is 2. So I have 2x squared. These 5's cancel. So I just have negative x. And then this is going to be minus 10. Alright, so we have that. This could be the answer if this trinomial is not factorable. But let's try. Let's try to factor it and see. So if we attempt to factor this pink trinomial, and we should definitely bring down the 5 just in case it is factorable, then we think to ourselves, first we look at the 2x squared, and we think, well, you know, there's only one way to factor that, 2x and x. Next we look at the 10. What do we think about the 10? Well, the 10 could be 2 times 5, or it could be 1 times 10. Those are the only options. I'm going to try the 2 times 5 first. I am not going to waste my time doing 2 and 5 like that. That creates a GCF right here. Since this doesn't have a GCF, I already pulled it out, then this should not have a GCF. So I will go much quicker by not wasting my time with that option. Instead, I will only try the 5 here and the 2 here. Now, inner plus outer equals middle. Inner, I have 5x. Outer, I have 4x. Okay, I'm trying to get a middle of negative x. Can I get a negative x, negative 1x, out of 5 and 4 if I pick the signs right? Yes, I can. If I have a negative 5 and a positive 4, that would make negative 1. So there's my negative 5, and there is my positive 4 outer. Okay, so this is great. Am I getting negative 10? Yes, negative times a positive is a negative. So this is the correct factorization. There it is. Okay, number 14. Well, I'm looking at all this mess, and clearly this is all about a GCF. That's all this is about. So let's look at the number part. So do not get distracted by all the variables right now. Right now, just look at the 6, the 24, and the 12, and the 18. That's it. In fact, if I were you, I would focus on the smallest number. Okay? Obviously, 6 is divisible by itself. Are the rest of these numbers divisible by 6? Yes. All 4 of these numbers are divisible by 6. So 6 must be the GCF, number-wise. So let's pull that out. 6. Now, as far as the variables go, it's easy. The GCF is just going to be the smallest one. So look at the x's. We have x to the 6th, x to the 5th, x to the 7th, and x to the 3rd. What's the smallest amount? Obviously, that's x to the 3rd. So that's what you pull out and make that part of your GCF. Okay? Now look at your y's. Alright, what's the smallest amount? Yeah, y squared is the smallest, so that's what you pull out. Okay, the variables are easy. Alright, now make a big old set of parentheses, okay, for everything that gets left behind. Now, to know what gets left behind, what you do is you divide by your GCF. Okay, so I'm going to divide, what color should I use? Alright, my GCF is 6x to the third power y squared. So I'm going to divide everything by that. Okay, 6x to the third power y squared. 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 I'm just dividing everything by my GCF. So let's just take it one term at a time. Six divided by 6, those are going to cancel out. Alright, so no more 6's. X to the 6th power divided by x to the third power, that's going to leave me x to the third power. Okay, you subtract basically. I think of it as canceling. These three x's are going to cancel out 3 of these x's, leaving 3 behind. The y squared, both of those will cancel out, so no more y's. Now the next term, alright, I see the minus, so I'm going to bring that down. 24 divided by 6 is 4, so I'm going to have a 4. These 3 x's are going to cancel out 3 of these x's, but that's going to leave x squared. These 2 y's are going to cancel out 2 of these y's, but that's going to leave y squared. Okay, 12 divided by 6 is 2, so I have a 2. These 3 x's cancel out 3 x's, that's going to leave x to the 4th power. These 2 y's will cancel out 2 of these y's, but that's going to leave a y. 18 divided by 6 is 3. X to the third and x to the third cancel out completely, so no x's. These 2 y's will cancel out 2 of these y's, and that's going to leave y to the third power. That's it. So this is the answer. Haha, number 15. Funny story. Way back in 2014, such a long time ago, I can almost not remember it. I had told my students that there was only one prime answer on this whole test, but I wasn't counting on number 15 because somebody made a mistake. So back in 2014, originally this was a plus. Alright, if this was a plus, then watch what would have happened. It's so funny. If we tried to factor this, n squared would be n times n, and 12. The possibilities for 12 are it's either going to be 3 times 4, or 2 times 6, or 1 times 12. Alright, since the leading coefficient is 1, we can immediately begin to look for the -4 right now. The only thing that has a shot is the 2 and the 6. That's the only thing. So you go 2 times 6. Now, inner plus outer equals middle, right? You're familiar with this. So inner, you have 2n. Outer, you have 6n. Alright, the only way you're going to get -4n is if you have a -6 and a +2. So great. So that means +2 and -6. Oh, but now you see the problem. +2 times -6 would make -12, not a +12. Okay, so this was unfactorable. So that means that should have been prime. Alright, but there's another problem coming up later that's prime. So that made 2 primes. So, if I had to do it all over again, I would make this -12. Okay, and in that case, then this works out great. +2 times -6 make -12. Everybody's happy. So in this universe, the answer is n plus 2 times n minus 6, and it's not prime. Alright, so let's pretend we live in this universe where my colleagues and I did not make a mistake. Okay, moving on to number 16. This is the difference of two squares. There's no GCF here. Notice how short it is. There's no middle term. Difference of two squares is one of my favorites just because it's so easy. You know, everything just splits right down the middle, right? 4c squared, that's 2c and 2c, all right? Same thing twice. The 49, let's go 7 times 7, even Steven. But the only thing is we need a plus and a minus. So kabam, all right? We've memorized the pattern. We know that's the answer. But it might be interesting for you to just understand why this is working. First of all, please understand that when you have this missing middle term, right? So I have 4c squared, right? And I have this minus 49. Why am I leaving a space? Because normally there's a middle term. So understand that what's missing is the linear term, the c term, 0c. So if we look at it this way, then if we factor this as usual, right? 4c squared, that's 2c times 2c. Negative 49, that could be positive 7 times negative 7. But normally we go, okay, inner plus outer equals middle, right? So let's see why this works out. Because the way we have it right now, inner, we have a positive 14c, right? 7 times 2. Outer, we have a negative 14c. So can you see that when I put these together, I do get 0c. And that's why we don't write it, and that's why we get 4c squared minus 49. So it does work. Now this is the one that was supposed to be prime. Okay, there's no GCF, it's only two terms. There's just not a darn thing you can do with it. So this should have been the easiest problem on the test. You just look at it and you immediately know it's prime. You know, it's not even a challenge really. Okay, nothing you can do with it. Alright, so number 18. We're going to solve by factoring. So let's go ahead and factor this, but this is an equation, so we're not going to just stop. We're going to keep going. So x squared is x times x. 6, well, you know, that could either be 2 times 3 or 1 times 6. Keeping an eye on this middle term of 5, well, really either one of these could give us 5. So let's go ahead and try the 2 and the 3. Inner plus outer equals middle. Inner, I have 2x. Outer, I have 3x. That could give me 5. To get a positive 5, I need both of these to be positive, which makes both of these positive. Does that give me a positive 6? Positive times positive is a positive. So, yes. So that's great. But now we don't stop here. We're solving now. This is an equation. So we're going to go ahead and set these factors equal to 0. Okay, so we're going to go x plus 2 equals 0 and x plus 3 equals 0. If you do that, then we go minus 2 on both sides. Okay, that gives us x equals negative 2. And here I'm going to subtract 3 on both sides. Whoa, missed. And that's going to give me x equals negative 3. Alright, so these are the solutions. Okay, now notice that I only have an x squared term. Alright, I do not have an x term. The middle term is missing. So when I'm solving an equation like this, one of my options is to use square roots. So that's what I'm going to do. So here's one way to solve this problem. I could get the x squared by itself. I could add 192 to both sides. Okay? If I do that, then That gives me 3x squared is equal to 192. Then I would divide both sides by 3. Okay, cancel those out. So that's going to give me x squared equals alright, so I have 192 divided by 3. Alright, and that is 64. Okay, and then I need to take the square root of both sides. Alright, don't forget your plus or minus. So that's going to give me x equals plus or minus 8. Alright, which I'd like you to write separately as x equals 8 or negative 8. So that is the answer. Alright, now here's how I could have done it by factoring. What's the first step of factoring? Pull out the GCF, right? So I could have done it this way. I could have pulled out my common factor of 3. Alright, so if I divide everything by 3, then I end up with x squared minus 64. Alright, then maybe you realize that this is the difference of two squares. So this can factor very quickly as x plus 8 times x minus 8. Okay, so I've still got the rest of this. Now, 3, whoa. Normally we set all three of these factors equal to 0. But 3 cannot equal 0, so forget about that. But the rest of these we have to deal with. So x plus 8 equals 0, x minus 8 equals 0. Right? If we subtract 8 from both sides, and here if we add 8 to both sides, then that's going to give us x equals negative 8 and x equals positive 8. And of course that's the same thing we got doing it the other way. Okay, so two ways of solving the same problem. You do whichever way makes you happy. Alright, this video is getting slightly longer than I like, almost up to 18 minutes. So I'm going to do one more, and then that's sort of the end of the page. So this is a completely different type of problem. So that'll be a good stopping point. So this problem's kind of the same. Well, you know, it's a solving a quadratic equation problem. But this one does have all of its terms. We've got an x squared term, we've got an x term, and a constant. So let's do this the old-fashioned way by getting 0 on one side. So let's subtract 3 from both sides. So that's going to give me x squared plus 2x minus 3 equals 0. And then let's factor this, hopefully. X squared is x times x. 3 can only be 3 times 1. Okay, inner plus outer equals middle. Inner, I've got 3x. Outer, I've got 1x. I need to get the middle of 2x, positive 2x. Is there a way to get positive 2x out of 3x and 1x? Well, if I have a positive 3x and a negative 1x, that will do it. So positive 3, negative 1. Is that going to give me a negative 3? Well, yes. Positive 3 times negative 1 is negative 3. So it has been factored correctly. Now, we need to take these factors and set them equal to 0. Okay, so that means over here I'm going to do x plus 3 equals 0 and x minus 1 equals 0. Okay, subtracting 3 from both sides, adding 1 to both sides. That's going to give me x equals negative 3 and x equals 1. And that's it. These are the solutions. Alright, that's plenty enough for one video, and we will pick up the next video with solving quadratic inequalities. I will see you on that video.